Okay, it's the reverse of differentiation. One of the practical uses of integration, apart from just using it to solve calculations, integration can help you to find the area under a graph. Okay, if you make any graph and you're good at integration, you'll be able to find the area under that graph. So we express this as a partial fraction earlier. It was equal to 1 over x plus 1 plus 1 over x plus 1 or plus x plus 2 plus 2 over x plus 3. So here what's going to happen is we're going to integrate each fraction separately. All right, so we'll bring the integral sign here, the integral sign here, and the integral sign here. Oops, that's an ugly integral sign. Let me remove. Right. So usually the rule whenever you're integrating such fractions, all right. For example, let me just illustrate the rule that's there. Okay, so for example, 1 over x, if you want to integrate it, right, you're going to write the natural log and you put this absolute value here, this line, x plus 1, then you put again this line here. So you get the natural log of the absolute value, and then you're going to derive this x plus 1. So you're going to put over dy dx x plus 1. Okay. So to derive x plus 1, we start using the power rule. All right. This is x to the power 1. So use the power rule, you multiply the exponent by the coefficient. In this case, our coefficient is 1. 1 times 1, that is 1. Then, after you do that, you have to subtract 1 from the exponent. So you're going to remain with x to the power 1 minus 1, that is 0. If you remember, x to the power 0 is the same as 1. So when we when we differentiate x plus 1, you just remain with 1. So the answer is the natural log of x plus 1 divided by 1, which we can put here. Natural log x plus 1 over the derivative, which is 1. We integrate this next fraction here. One over x plus 2. So you're going to write the natural log, and then you put this line here, x plus 1 over dy dx. So you're going to derive, this is x plus 2 here. You're going to derive x plus 2, right? So remember, in differentiation, numbers without a variable, they just disappear, okay? That's why you saw even this one here, it just went. So even here, this 2 is just going to go. The derivative of x to the power 1, again, as you can see here, it is 1. All right? So here you're going to put the natural log of x plus 2 over 1. We now derive this fraction here. So we have 2 over x plus 3. So colleagues, with this type of questions, if the numerator is not 1, take it out. All right. So this 2, we just bring it in front here. So it becomes 2, then there, integrate 1 over x plus 3. All right. For this process to happen, your numerator has to just be 1. So whatever number which is apart from 1, remove it out so that you have a 1 on top. Okay. So this is going to remain 2 times the natural log of x plus 3 divided by the derivative of x plus 3 dy dx. Again, this 3, it goes. X to the power 1, the derivative is 1. Right? So we can write our answer here. Plus 2 the natural log x plus 3 divided by the derivative of x plus 3 is also 1. So your answer is going to be the natural log of x plus 1 plus the natural log of x plus 2 plus 2 the natural log of x plus 3. So that is their answer. Any questions?